Moving on with the review, let's go over exponents. What does 2 to the power of 6 mean? It means that you multiply 2 by itself 6 times. So 2 to the power of 6 is equivalent to multiplying 2 6 times. So when you see 2 to the power of 6, we call the math expression a power, or that it is in an exponential form. Let's take a look at parts of power. So power is this. But what about parts of the power? We know that this is an exponent, and that 2 here, let's see, 2 here is called the base. So when we're referring to power, we're talking about the entire form, not just exponent or base. So keeping this in mind, fill in the following chart. Repeated multiplication, it says 3 times 3 times 3. And if we were to write that into exponential form, it's 3 to the power of 3. We know the value of this is 27. Repeated multiplication, here, how many 4s are there? 1, 2, 3, 4, 5, 6, 7. 7 4s. So in an exponential form, we can rewrite it as 4 to the power of 7. If you punch into your calculator 4 to the power of 7, you'll get a big number. It's 16,384. All right. So next line, 5 to the power of 4. If we want to write this as a repeated multiplication, we're going to rewrite it as 5 times 5 times 5 times 5, which is, when we evaluate it, which equals to 625. And there's a typo here. It's 256. I want you guys to figure out the exponential form and repeated multiplication that would give a value of 256. You can pause here for a second and come back when you are done. All right, so it is 2 to the power of 8. As a repeated multiplication, we can rewrite it as 2 times 2 times 2 and so on. And you can double check by putting into the calculator. So there can be more than one way to show the exponential forms of numbers. For example, 625, you can multiply 5 4 times, but also you can multiply 25 twice to get 625. Okay, so they're both correct, unless I specifically tell you what kind of base I want you to use. So let's try the example here, 4,096. It's an even number, so I would first divide 4,096 by 2 first. And we're going to do this until we have nothing else to divide. The reason why I chose 2 was because this value is even. So because I know it's even, it's divisible by 2. So I just divided by 2. So we are with 2,048. You're going to have to divide once more of 2. That's 1,024 divided by 2. That is 512. Hey, let's divide by 2 again. 256. 256. Need to divide 2 again. That's 128 divided by 2. We have 64. Divide by 2 again. 32 divided by 2. Alright, so there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so let's first write down in terms of base 2 as 12 as an exponent. We'll move on, but look at this line here. Notice that we used a bracket to group a couple of them. So let's try that. Because we have an even number of 2's, we can group them, we can pair them. So let's do it. 2 2's here. Okay, perfect. So we have 6 group of 2, product of 2's. All right, so we have 4, this is 4, times 4 times 4 times 4 times 4 times 4. And this is equivalent to 4 to the power of 1, 2, 3, 4, 5, 6. Lastly, we can do one more pair. We can do 4 times 4, 4 times 4, and 4 times 4. So this one equals to 16 times 16 times 16, which is 16 to the power of 3. So we just confirm that we can write 4,096 in 3 different exponential forms. We know that 2 to the power of 4 equals to 16. What are the answers to the following expressions? So we're going to take a look at this negative base exponent, or negative base power. Let's rewrite that into repeated multiplication. So we have negative 2 times negative 2, times negative 2 times negative 2. And we know that negative times negative is positive, so there's negative times negative is becoming positive, and then negative times negative is positive, so positive times positive is a positive number. So we know this result will be a positive value. Lastly, we know 2 times 2 times 2 times 2 is 16. So we can say that negative 2 all to the power of 4 is positive 16. For second expression, that exponent 4 is only referring to the base 2, not negative 2. So if we were to rewrite that, we can take the negative out by making it a multiple of negative 1 and say 2 to the power of 4 after. And we know 2 to the power of 4 is 16, so this is equivalent to saying negative 1 times 16, which is negative 16. All right, so this one looks a little bit more tricky. All right, so this 4 exponent is referring to the base of negative 2. We already solved it as a first example here, so we can reuse it. Let's rewrite that. Negative, because there's negative here, negative 1 times. We're going to use that from here, so we have positive 16, which equals to negative 16. Keeping this in mind, fill in the table below. So repeated multiplication, it has negative outside the bracket. So we can actually just say negative. Base has to be 3, and how many 3's are there? 4. So we can say that the value of this is negative. And when you punch it into a calculator, you might have to use either this notation, this button, or this button, x to the power of y button, or y to the power of x button. On my calculator, I have the mountain button, so wherever that works for you. So we have negative 81 here. Next row, we have negative 4 times 5 times 1, 2, 3, 4, 5 times. So we can rewrite that as base is negative 4 because that's what we're multiplying many times. We're multiplying negative 4 5 times. And now when you're putting into a calculator, you have to open the bracket and plug in negative 4 as a base. And then you press to the power of 5. That's negative 1024. Next one, we're now given the exponential form. So we can rewrite that as repeated multiplication. So negative 3 times negative 3 times negative 3. 3 times. And you can kind of see that there's odd number of negatives. So our value is going to be a negative value. It's going to be negative. And 3 times 3 times 3 is 27. All right, next one. We're now given the value, which is negative 32. And we need to find out what kind of exponential form it has or repeated multiplication. So first step I would take would be just double check if it's even or odd number. Because 32 is an even number, I'll try to expand or divide out 2's. And not only that, this is negative, so I'm going to try taking the negative 2 out. Alright, so let's take the negative 2 out first. So 32 divided by negative 2 is 16, so that becomes positive. Alright, so we'll try once more, divided by negative 2, which is negative 8. And then we're going to do once more, divided by negative 2. That's 4. If I do divide by negative 2, it becomes negative 2. So we have 5 negative 2's. So let's just double check. Is 2 to the power of 5 32? Yes, it is. So we can rewrite this as negative 2 to the power of 5. What you might notice, though, is that if you were to take out the negative and rewrite that and just with 32, you can actually do that as well here. If you take out, let's say, negative 1 out, and say 2 times 2 times 2 times 2 times 2. Then we can actually just say that this is equal to negative 2 to the power of 5. And we'll discuss why in this case the sign, where the location of a sign doesn't matter in the next lesson. All right, next one. Negative times negative 3 to the power of 5. Let's first rewrite that into repeated multiplication. So we have Negative 1 outside. Negative 3, 5 times. All right, so let's take a look. So negative, we know that this value is going to be a positive value because how many negatives do you see? 1, 2, 3, 4, 5, 6. Even number of negatives. So what's going to happen is that the negative will be canceled out because you're multiplying two negatives, it becomes positive. So we can just say that overall it's going to be positive, and you can count how many 3's we have to multiply. We have 3 to the power of 5, and you can just punch into your calculator 3 to the power of 5, which is just 243. All right, next example. Negative times all those negative 5's. So we can rewrite that into exponential form. Leave the negative out. And we're going to do base is negative 5. And we're going to count 1, 2, 3, 4, 5 of them. So exponent is 5. All right, so, and again, we actually could double check here. Is this value going to be positive or negative? Let's take a look. So we have 1, 2, 3, 4, 5, 6. 6 negatives. These negatives will cancel out, and this value will be a positive number. So we can say that we can just keep 5 to the power of 5. And when you punch into your calculator, this just equals to 3125. Let's go over exponent laws. Number 1, when multiplying powers, let me highlight some of the stuff, with the same bases, then we add the exponents. Okay, for example, 2 to the power of 2 times 2 to the power of 3 equals, keep the base, and you're adding the exponent. So 2 plus 3, which is 2 to the power of 5. And you can double check this by punching into the calculator. Number 2, when dividing powers with the same bases, we subtract the exponents. For example, 2 to the power of 3 divided by 2 to the power of 1. So we have the common base, 2, an exponent, 3 minus 1, which is 2 to the power of 2. Number 3, when you have an exponent to a power, we multiply the exponents. So let's say 2 to the power of 2 all to the power of 3. This is when we have to multiply the exponents. So the answer would be 2 to the power of 6. Number 4, anything to the power of 0 is equal to 1. So for example, if we have a power 2 to the power of 2, this is the same thing as 4. Let's try dividing that 4 by the base 2. Divided by 2. And let's try the left-hand side as well, divided by 2. 2 squared divided by 2 is equivalent to having 2 to the power of 1, which equals to 2. We'll try once more by dividing 2. So 2 divided by 2 is 1. But notice our exponent here went 1 down. So from 2 to 1, then 1 to 0, so we need 2 to the power of 0 equals 1 when we're dividing it by 2. So this is why anything to the power of 0 is equivalent to 1. So this is it for the exponent review.